All right, we are on page 2 of your packet. Graphing circles is what we're going to look at today. This is just a repeat of what we did yesterday. You can put it back on here again if you want to. Same formula. We're going to be using it a little bit different today. Yesterday we took that, we found the center, we found the radius, whether it was from a graph or just off of an equation, or made the equation. Here they're going to give us the equation of a circle. We're going to identify the center, we're going to identify the radius, and then we're going to graph it. Okay? So let's look at number 1 down here. My center would be what? What do you guys think? -2, +5. Okay, remember it's always the opposite. So if this is +2, this would be -2. If this is -5, this would be +5. And that's my center. You can go ahead and plot it if you want to. -2, 5. Okay, and then we know r squared is 9, so then that means my radius would be 3. We just got to make sure we take the square root of it. Okay, we're going to make a circle here. So to get a circle, we're going to plot 4 points from the center. And so we're going to count 3 units in every direction we can. We cannot go diagonal, but we can go right, up, left, and down. So we're going to go right 3. We're going to go up 3, left 3, down 3. That's going to give us 4 points. And we're going to connect those 4 points to make the best circle that we can. It may not look perfect, but you get the idea. The center should be equidistant on all sides of that circle. Okay, number 2 is not much different. The only thing different here would be if you had y squared, this would just be a y value of 0. So then my center would be at 7, 0. And the square root of 1 is 1, so my radius would be 1. So it's going to be a really, really tiny circle right there because it only has a radius of 1. All right, so here's where the algebra kind of starts to come in. And kind of like we said yesterday, why do we do this in college algebra when it's really kind of a geometry type concept when we're graphing some type of geometric figure? And so there's going to be some algebra in play because of the equation that we have for this circle. So we're going to look at some different examples. We're still trying to find the center and the radius, and then we're going to graph it. But it's going to look a little different here. Because this right now is not in standard form, and that's what this is talking about. So what happens if the equation is not quite in standard form? We got to do some things to get it there, okay? So first up here, when we are in standard form, we're going to start with a real kind of a basic one here. We don't want any coefficients in front of the x squared and the y squared. And right now that coefficient is 5. So we're going to divide all of these by 5. That gets rid of our coefficient. So our equation here would be x squared plus y squared equals 16. My equation is now in standard form. And it doesn't really look like standard form because I know typically we're used to seeing parentheses, but that means both of these would be 0, 0, right? X minus 0 and y minus 0. So my center here is really just at 0, 0. And that's kind of like the generic circle, kind of like we talked about with transformations where we move it left, right, up, or down. If there's nothing connected to the x and the y, then my center is at 0, 0. A lot of times we talk about that with like a vertex of some type of graph. And then here my radius would be 4. So we're going to start at 0, 0. We're going to go right 4, up 4, left 4, down 4. And that would be our circle. All right, on number 4, the only thing we want on this side over here is the constant, the one that doesn't have any x's or y's attached to it. On the other side, we want the x squared and the y squared on the same side. So on this one, we're simply going to add x squared to both sides. And so we have x squared plus y plus 3 squared equals 25. On this one, there's no division to do. We don't have any coefficients. Right now, it's in standard form. Now it's in the form we want it to be in. And so my center here, there's nothing attached to the x, so that's just going to be 0. My y would be -3. My radius would be 5. Okay. And once we have those two pieces of information, we're just going to plot. Always start with the center first, and then we plot our radius. There's our circle. Okay, so our goal is to get it in the form that we want it in, or we call that the standard form of the equation. Okay, number 5 is kind of a combination of the two of them. We want the x's and y's on one side. We want the constant on the other side. So basically what we're going to do is we're going to move this over here. We're going to move the 8 to the other side. So I'm going to leave the 2 and the x minus 1 squared here. Okay, I'm going to add, and this is all connected. We're not doing any distributive property or anything like that. We're going to add this whole expression to the other side. So we're going to add 2 y plus 6 squared equals, and then we're going to add 8 to the other side. So really what happens is these two flip-flop trade places. X squared and y squared on one side, constant on the other side. That's the form we want it in. This one also has coefficients kind of like that one we did before. So here we're going to get rid of those 2's by dividing everything by 2. We've got to make sure we do it all the way across. And then we have x minus 1 squared plus y plus 6 squared equals 4. And now it's in the format that we want. So my center would be 1, -6, and my radius would be 2. Really be careful here. Probably the thing that happens a lot right here is we forget to take the square root, because 4 is a fairly small number, so we see 4 and we just write 4, but we got to make sure we take the square root. It's a lot more obvious like when it's like an 81, and we know that we can't have a radius of 81. We'd have to take the square root of 81. But when it's a smaller number, sometimes we forget to take the square root. We got to make sure we take the square root there. So we go over 1 and then down 6, and then we right 2, up 2, left 2, down 2. So the size of that circle is going to change based on the radius. The bigger the radius, the bigger the circle from the center. we won't do all three of these down here. But this one, we've talked about completing the square before, but it's been a while. It goes all the way back to the quadratic chapter. So it's been a couple of months since we've talked about completing the square. It was one of the methods that we used to solve quadratics. We did like graphing, we did factoring, we did the quadratic formula. We also did completing the square, but we didn't spend a lot of time with completing the square because it's probably not the go-to method to solve quadratics. We also used completing the square when we wanted to graph a parabola and we wanted to put it in vertex form. So there's a couple of situations where we've used this. We just haven't done it a lot, but we're going to see it used here to be able to put our equation, our original equation here, into the standard form that we want. Okay, so in this case here, we're going to go x squared plus 6x. We're going to put our two things together that we want that are alike. So x squared goes with 6x. Y squared, there's no y's to go with it. And then -5 is going to stay on the other side because there's no x or y's connected to it. It's just a constant. So it stays over there. So we move all the constants to one side. We kind of rearrange and get our x's together. We get our y's together. If there's any other y's to put together, just kind of rearranging it. Okay? So the only thing that we can complete the square on is ones that have both the a value and the b value. So we're missing the c value for this trinomial, basically. It's going to be a trinomial. So when we complete the square, we're going to, this is what we always did, was draw the blank in here. And we got to fill in this blank. You got to figure out what number goes in there. We want to make it a perfect square trinomial. That's why we call it completing the square. We want to make it a perfect square trinomial. And so when we did this, what we did was we took that middle number, the 6 in this case, the b value, and we're going to take 6 divided by 2, and we're going to square it. Always divide by 2 and then square it. So 6 divided by 2 is 3. 3 squared would be 9. But whatever I add to one side, I always have to add to the other. We got to keep the equation balanced. So if I add 9 to the left side, I also got to add 9 to the right side. So I'm going to add 9 over here as well. We're going to rewrite this as in factored form, basically. So if we said what multiplies to get 9 and adds to get 6, it's the same number I get when I divide this by 2. It's 3, right? And so I could say x plus 3 and x plus 3 are my two factors, but instead of writing it as x plus 3 and x plus 3, we're going to really write it as x plus 3 squared. We don't have to do anything with the y squared. And then over here on the right-hand side, -5 plus 9 is 4. Now the good news is we get a nice perfect square. And that's not always going to happen, but we feel pretty good when we get a nice perfect square that we've probably done something right. Okay, but don't get freaked out if you don't get a nice perfect square there, because that may not always happen.
Why does the 9 disappear on the left side?
Because what we did was we factored this trinomial. So if I took x squared plus 6x plus 9 and said let's factor it, okay? What multiplies? What'd you say?
It'd be x plus 3 and then x plus 3?
Yep.
Okay.
And so we have 2 of them, so we could also just write it as x plus 3 squared. If I were to FOIL this, then it would get me back to here, basically. Does that make sense? Okay. And then radius is 2, so -3, 0 is my center. We have a radius of 2. And then we make our circle. Okay, one more. We're going to skip over 7. We're going to go down here to number 8. Okay, number 8 has both x and y. So we're gonna have to complete the square twice here, basically. And we're gonna have to move some stuff to either side. First thing we're always gonna do is we're gonna rearrange everything. I know that this 2y needs to come over here. If I had a constant that was on the left, I would move it to the right. We don't have any constants on the left. So the only thing that really needs moved over is the 2y. But I'm also going to put the like variables together. So when I rewrite this equation, I'm going to go ahead and put my blanks in here as I do this. Kind of running out of room here. But I moved the 2y over. I had to subtract 2y over here. So that's why this is a negative 2y. Everything else stayed the same, but I'm just rearranging and putting things together that are alike. Okay? So we have to complete the square twice. On the last one, we only had to do it once because we didn't have anything that was attached to the y squared. It was just y squared with no other y value there. So I got to complete the square here, and I also have to complete it here. You can write it out if you want to, but remember we're going to take 14 divided by 2, which is 7, and then we're going to square 7, which would become 49. And what I always like to do is go ahead and add it to the other side, so I don't forget to add it to the other side. If you add it to the left, you got to add it to the right. Okay, we're going to do the same thing here. Negative 2 divided by 2 would be negative 1. When I square negative 1, I get 1. So we got to add 1 to the other side as well. We're going to rewrite both of these in factored form. Okay, so we're going to have two different expressions, two different sets of parentheses. Whatever I get when I divide by 2 is the number that we want. So 14 divided by 2 was 7. So this is going to be x plus 7 squared. And we know that that's going to work because 7 times 7 is 49, 7 plus 7 is 14. It should make both of these numbers work. But it's simply the number that I get when I divide by 2. Okay, over here, when I took negative 2 divided by 2, this is where you got to be careful. Watch your signs. This would be y minus 1 squared. Because negative 2 divided by 2 would be negative 1. And then over here on the right-hand side of the equal sign. Negative 41 plus 49 would be 8. 8 plus 1 is 9. Once again, we get a pretty good feeling that we did something right if we get a number that's a perfect square. Numbers like 4, 9, 16, 25, 36, 49, numbers like that. When I see a perfect square there, that gives me a pretty good feeling that I did something right. We are now in standard form. This is the form we want, right? So now we just identify the center. Negative 7, positive 1, with a radius of 3. And then we make our circle. Okay. Questions on completing the square? That's something that we didn't do a ton of before. So that's kind of something, you know, a little bit, I won't say new, but something we didn't spend a lot of time with. All right, for your homework, we're still on the same page as we were yesterday, which is homework 1, the very first page in your homework packet. Day 2 assignment. Six problems yesterday, 6 problems today. And my thought is you should be able to get, hopefully you already have yesterday's done, you get these 6 done, and then you don't have anything that we'd like to work on. I know you guys will be disappointed by that.